And on behalf of the Manx National Farmers Union, welcome here today. Feel really privileged to have Professor Myles Allen here doing a talk for us today. I had the privilege just before COVID in 2020 to listen to him live at a conference, and he left a lasting impression on me. As the Manx National Farmers Union, we firmly believe that agriculture in the Isle of Man is part of the solution, not the problem to climate change. Before we get underway, I'd just like to quickly hand over to Chris Neal, our Chairman of Environment and Land, just to give a quick introduction before we hand over to Professor Myles Allen. Thank you.
Thanks, Ian. As Chairman of the Manx National Farmers Union Environment and Land Committee, we decided that after our initial research that the MNFU commissioned, we identified that food production can actually coexist in harmony with improving biodiversity, nature, as well as capturing carbon and sequestering carbon from the atmosphere. To date, we've been struggling to get our message heard by government that we want to be leaders on this and not just followers. So we decided that our next step was to invite a high-profile speaker, invite you guys here today to talk about climate change, farming, and how we need to start measuring food production's contribution to climate change and how the Isle of Man can become more sustainable, both in terms of climate and food production. So we decided we needed somebody that was well qualified. We needed somebody like a professor. We needed somebody that understands net zero. Ideally, somebody that understood and has been part of the IPCC UN Intergovernmental Panel for Climate Change for its 3rd, 4th, and 5th assessments. Somebody that understood the role of methane within the carbon cycle, and somebody that had influenced governments right across the world. So, ladies and gentlemen, it gives me great pleasure to introduce you to Professor Myles Allen.
Thank you very much. Well, thank you very much indeed. And I must say, I'm very sorry indeed not to be with you in person. It just wasn't possible this particular week. But I do hope. I've never been to the Isle of Man, and I'd love to visit at some point. So we'll have to chalk that up for the next time. But I'm very, very happy to talk to you this way, and thank you for accommodating me this way. I can see a few people in the room. Feel absolutely free to sort of wave your arms above your heads or something if you can't hear me. It's always or just interrupt if I say something that is either inaudible or incomprehensible, because it's always quite, it's always more of a challenge giving a talk this way, where you can't really sort of read the room to work out who's asleep and who's following and so on. But it is an important topic, and I hope you got my slides all up and so on. You can see everything, and you can hear me okay in the room. Give me a wave if you can hear me. Thank you very much. Okay, I appreciate the feedback, just to sort of confirm that I'm not just speaking into the abyss. So I mean, I'm talking very specifically about methane here, and just to manage your expectations, I'm not a soil scientist, so carbon sequestration in soils is another very important topic that I know that you guys are working very hard on. I have colleagues who work in that field, but my particular interest in this space is how we quantify the role of methane in agricultural emissions. And if I just, let me just get in the right screen, so there we go. So the challenge we face is that we absolutely, globally, we need your help. We need farmers' help to meet our climate goals. There's, many papers get published making the point that if we leave agriculture out of climate policy, we're very unlikely to meet the goals of the Paris Climate Agreement. And there's every reason to include agriculture in climate policy, because agriculture is one of the sectors that's most vulnerable to climate change. So it sort of makes sense on both fronts. And part of this is we need to stop the rise and ideally start to reduce methane emissions. Methane is a very important greenhouse gas. It has caused warming already, and we'll talk about that in a minute. And we need to, and it's causing a lot of warming at the moment globally, but and so we need to do something about that. But we have a sort of rather unnecessary obstacle in the way of addressing methane's impact on climate, which is that it's very widely misunderstood. And the reason for the misunderstanding is actually a bit of a embarrassing one, if you like, in that it goes back 30 years to a rather clunky way of comparing methane to carbon dioxide, which is to treat methane emissions as just part of your carbon footprint, as some kind of carbon dioxide equivalent emission. And as I'll explain, methane and carbon dioxide just don't behave like each other. And therefore, the idea that 1 ton of methane is worth a certain number of tons of carbon dioxide is never really going to work, and has led to much confusion over the past 20 years or so. So we have an opportunity, though, which is, I think we do understand how methane does work and how it affects global temperatures. And we have an opportunity, if we were to come to this space now, without this sort of 30 years of heritage of this idea of carbon dioxide equivalent emissions and conventional carbon footprinting, we would almost certainly take a very different approach to the one that has been taken up until now to methane, and just focus on the implications of decisions on global temperature. And where I think you have an opportunity, you, the farmers of the UK, you need to get together and argue coherently with DEFRA that incentives for farming should be based on warming outcomes. If you're causing global warming, then you probably should be looking at your farming practices and adjusting them to stop doing so. If you're reducing global temperatures through your farming practice, you deserve to be rewarded for that. And if you're not doing anything, then you should be treated accordingly. This would make it easier, I believe, to include agriculture in climate policy. It would make it much fairer on particularly livestock farmers. And I believe it would actually result in faster reductions in the current rate of warming than what we're doing at the moment. So let me start with sort of where we're at. And this is on the left, the UK's total emissions in the conventional accounting system that I mentioned, where all gases are treated as some kind of carbon dioxide equivalent. And as you can see, the UK's total emissions peaked in the 1970s, have been going down ever since. The red is carbon dioxide, blue is methane, green is nitrous oxide. And you can see that both carbon dioxide and methane have been falling since the mid-1970s or so, for different reasons. But on the right, you can see the contribution of agriculture. And notice I've scaled up the scale. So agriculture, the scale's blown up by a factor of 10, so that you can see what agricultural emissions are. And the same, at first glance, you might think these two graphs look fairly similar, but you'll notice immediately the colors are rather reversed in the agriculture panel. Unlike the UK as a whole, whose emissions are dominated by carbon dioxide, agriculture's emissions are dominated by methane, with a large contribution from nitrous oxide and very little coming from carbon dioxide. I think this is part of the reason we've got this rather problematic accounting system for greenhouse gases at the moment, is that it was designed by people who were looking at the graph on the left, which is dominated by carbon dioxide, and methane's a bit of an afterthought. If our greenhouse gas accounting system had been designed by farmers, I believe it would look very different. And this is why we need to talk about this today. So that's what emissions have done. And here is what those emissions from the UK have done to global temperature. So the scale here is in thousandths of a degree, which doesn't sound very much, but the UK, of course, is only about a thousandth, somewhat less than a thousandth of the global population. So we shouldn't say, oh, well, we haven't caused that much warming ourselves. If you multiply up the amount of warming we've caused to the global population, it adds up to a pretty substantial number. So on the left is the warming caused by the UK's emissions. And there you'll see, again, like the emissions graph, it's dominated by carbon dioxide. But I want to point out to you a rather different shape here in the way carbon dioxide's causing warming and the way methane's causing warming. Notice when carbon dioxide emissions started to go down from the mid-1970s, all that really happened to that red line over here in terms of the warming they're causing is it slows down a bit. It's not accelerating upwards as it was earlier in the century. Whereas the methane curve in blue here, I'm looking at the left-hand plot here, the methane curve here is, by the way, can you see my cursor, my arrow? It might be helpful to point things out. Give me a wave if you can see the arrow. Yes, thank you. Okay, so I'll be able to point things out with it then. Good, thank you. So the blue curve here, you see, as soon as we started to reduce methane emissions, you can see the contribution of UK methane emissions to global warming started to come down. And of course, the same goes for agriculture. If we look at in the right-hand panel, agricultural methane emissions peaked in the 1990s or so and have been since falling. And that actually means that the contribution of agricultural methane emissions to global temperatures has been on a downward slope since 2000 or so. That's largely compensated for by continued warming due to nitrous oxide, but the result is that agriculture as a sector in the UK hasn't caused very much warming for the past 15, 20 years or so. That's very different from the impression you'd get from headlines about agricultural emissions. So this difference between emissions and warming that those emissions cause is at the heart of what I'm talking about. Let me just explain that with a schematic, a nice schematic diagram, and it is available, by the way, on that web link. And by the way, I'm very happy, I sent Sarah these slides, very happy for them to be circulated to you so that you can go back over them. And there's web links on the slides as well if you want more information on this. So when carbon dioxide emissions and methane emissions are rising, that's on the left here, they both cause warming. Carbon dioxide causes warming at an accelerating rate because carbon dioxide accumulates in the climate system. So the faster you emit it, the faster the warming it causes. Methane, in contrast, doesn't accumulate in the climate system. It has a relatively short lifetime, short in climate timescales, around a decade or so. So as soon as you put methane into the atmosphere starts to oxidize it. It starts to destroy it, turns it back into carbon dioxide again, and that means that the impact of methane emissions on global temperatures scales, roughly speaking, with the rate you're emitting methane emissions, whereas the impact of carbon dioxide emissions scales with the total amount you've emitted over all time. What this means is when we go to constant methane emissions constant methane emissions cause much less warming than nominally equivalent carbon dioxide emissions. So, which is at the heart of the problem of accounting that we're talking about. And the contrast is even bigger when we get to falling emissions. And of course, emissions have been falling from the UK agriculture over the past couple of decades, and we're planning for them to fall even faster. So these difficulties, these challenges of how we represent the impact of our emissions will get even worse the faster emissions come down. Falling carbon dioxide emissions cause warming to decelerate. It's a bit like just hitting the brakes in a car. As you slow down your emissions, the car comes to a stop. And you can see that red line leveling off there.